in the scorching Egyptian desert stands a physical anomaly. It has endured sandstorms, earthquakes, and the rise and fall of countless civilizations. Yet for thousands of years, the Great Pyramid of Giza has remained towering and intact. The sheer precision of this structure defies our usual understanding of the ancient world. It is built from roughly 2.3 million giant stone blocks, forming a base that is perfectly aligned to true north, without the use of a compass. And no matter how blistering the desert heat gets outside, the internal chambers stay locked at a constant 20 degrees Celsius. To fully grasp the sheer scale of what we are looking at, we have to look at the mass. This diagram illustrates the total weight of the Great Pyramid, coming in at roughly 5.75 million tons. If you put that on a physical scale, it would take 11 Burj Khalifas, the tallest building on Earth, just to balance it out. Because the ancient Egyptians pulled this off roughly 4,500 years ago without iron tools, pulleys, or even commercial wheels, it created a massive gap in our historical understanding. That vacuum has been filled with wild theories, everything from extraterrestrial architects to claims by the great inventor Nikola Tesla, who suspected the pyramids might have functioned as ancient wireless energy transmitters. But we don't need to look to the stars or science fiction for answers. Stripping away the myths reveals something much more impressive: the greatest forensic engineering and logistical operation in human history. The first piece of fiction to discard is the idea that millions of slaves were forced to build these monuments under the whip. Archaeological evidence reveals a highly organized workforce of roughly 30,000 skilled, well-fed, and specialized laborers operating in dedicated shifts. Their immediate hurdle was raw extraction. They had to carve out millions of dense limestone and granite blocks, some individual stones weighing up to 80 tons, and shaped them perfectly before they could be moved an inch. And they did this using a strictly Bronze Age tool set. We are talking about basic wooden mallets and copper chisels. Because copper is incredibly soft, it required constant sharpening and immense physical stamina to slowly chip away at the quarry walls. For the harder stones, like granite, they utilized natural physics. Workers drove completely dry pieces of wood into natural crevices in the rock face. Then they soaked the wood with water. As it absorbed moisture, it rapidly expanded, creating immense outward pressure that forced the solid rock to split. A combination of intense physical labor and a deep understanding of natural mechanics overcame the first hurdle of mass extraction. With the blocks completely cut, the builders faced an even larger logistical nightmare. Many of the heaviest granite stones used deep inside the pyramid were quarried nearly 800 kilometers away from the final construction site. Thanks to a recently discovered ancient papyrus diary, we know they took advantage of the Nile River. They built extensive canal networks to float these massive payloads on specially designed cargo boats right up to the Giza Plateau. But once those blocks hit dry land, workers still had to drag 80-ton weights across deep desert sand. And they had to accomplish this entirely without the benefit of wheels or mechanized vehicles. A specific wall painting inside the tomb of Jehuti Hotep provides evidence of their solution. It depicts workers hauling a giant statue on a wooden sled, with one person standing at the front, pouring liquid directly onto the sand. Here's the principle. Pulling a heavy sled over dry sand creates a pileup, causing massive friction. But pouring water ahead of the runners binds the grains together. This makes the surface rigid, cutting the pulling force in half. By mastering the elemental properties of their own environment, using the river to bypass distance, and water to manipulate surface friction, these ancient engineers turned an impossible transport problem into a repeatable system. Even with the stones at the site, the builders faced one final mechanical hurdle: lifting millions of blocks to the apex. For decades, the leading idea was the external ramp theory, suggesting a massive slope of mud and brick was built against the sides. But physics presents a major flaw. To maintain a shallow incline for dragging heavy stones, the ramp would eventually need to be larger than the pyramid itself. To solve this, researchers proposed the internal ramp theory. The Egyptians likely left a winding, corkscrew-like tunnel system inside the walls, pulling blocks up through the interior. Other theories suggest a specialized hydraulic lift system, trapping water pressure from nearby channels to float the massive stones upward block by block. While the exact lift method remains a subject of intense debate, the execution was a triumph of sequential planning, coordinating 30,000 people for 20 years to stack millions of stones with millimeter precision. Today, when we look at the Great Pyramid, we see a rugged mountain of exposed tan blocks. But to appreciate what the builders actually finished in 2560 BC, you have to realize that this is just the inner skeleton. In its prime, the entire monument was encased in highly polished white limestone. These smooth outer walls were fit so tightly together that the sides looked perfectly flat, reflecting the fierce desert sun like an immense diamond. And sitting at the absolute peak was a specialized capstone, often covered in gold or electrum. Known as a pyramidion, it caught the light to ensure the monument was visible from miles away across the landscape. And remarkably, this structure isn't done giving up its secrets. Modern engineers are currently deploying ground-penetrating scans and robotic rovers to crawl through narrow shafts, confirming the existence of unexplored hidden passages still waiting in the dark. By stripping away the myths of outside help and examining the pure human ingenuity involved, the pyramid stands as a testament to what we are capable of. It reached its ultimate goal. It outlasted its creators by 45 centuries and continues to push the boundaries of modern discovery today.